In the previous video, I have shown you how to normalize the data that is derived from the shRNA library screen. In the series of the videos I'm going to show you later, that will include how you can actually identify the hits based on those data. In general, there are three approaches that normally people or researchers will use to identify the hits from the RNAi library screen. First of all, you can actually use the Z-score cutoff to actually determine whether the particular knockdown of a particular gene is significantly associated with a phenotype that you wanted. Or you can also use a statistical method called the redundant siRNA activity analysis, or in short, RSA analysis. And similarly, you can use another method which is called the RNAi gene enrichment ranking, or RIGA analysis. In the following videos, I'm going to show you in detail how you can actually use these three approaches to identify the hits from any of the RNAi library screen data. Okay, so one way to actually identify the hits is actually based on your Z-score. If you look at the Excel sheet that you have prepared previously, this is basically the Z-score that you obtain from the normalized data. Now, what you can see here, however, is that, for one particular gene, for example, in this case here, the AMPR1 genes, actually targeted by several shRNA. So what we need to do basically is to consolidate all these different shRNA and to see what is the effect of knocking down this particular gene has in terms of their cancer cell survival. So one way to do it basically to count how many shRNA in the particular how many shRNA that target a particular genes can induce the type of phenotype that we wanted. And in this case here, the phenotype that we want is actually to reduce the cell proliferation. And basically, we are looking for the Z-score that are in the negative value. The more negative it is, indicate that, the shRNA was actually depleted in the pool genome-wide shRNA and suggest that there are actually less shRNA in that particular pool. So basically what you can do is you can decide the cutoff whether you want to select for those genes that are actually minus more than minus 1.5 or minus less than 2 and so forth. You can decide that cutoff. But before you do that, so what I'm going to do is basically I'm going to create another Excel sheet blank here, and I'm going to populate all this information. The first thing I want to do is basically I want to get all the gene and also the shRNA into one column here, and then I will label this. This is all. Basically, these are all the genes that are covered under the current shRNA data set. So next, what I need to do is basically I'm going to filter it. For example, for BXPC3, I'm only interested in the shRNA that are less than or equals to say -2. So, and then I'm going to copy this list, into the Excel sheet here. So then you can then label this column as, well, hold on a second, it's still running. So you can then label the column according to the cell lines. So this, well, this is what you can do basically. Okay, that's good. So I'm just going to copy this. This is the BXPC line, and then similarly, I'm going to filter for, let's say, CF pack 1. So again, it's less than equals to -2. So again, the cutoff, you can decide what cutoff you want, if you want -2 or if you want -3, so that is fine. So actually, there's no well, what do you call it, that there's no absolute cutoff. So some people use -2, some people use -3, and so forth. But personally, I prefer to use -2, so that will give you quite a number of hits. At in the same time, it is also quite stringent as well. So now, so what you can do is basically you can repeat this exercise, and of course, do remember to label your cell line as well. So if well, you can do this with all the individual cell lines. So once you have done, basically, then you will actually get Excel sheet something that something look like this with all the cell lines and also with all the shRNA gene hits that are being identified in the data set. Okay, once you have populated all the cell lines and also the hits for each of the shRNA, you will get a table something like this. So the next thing what I'm going to do is basically I'm going to create a master list of the genes. So by copying this into a separate column, oops, sorry, I think I'm just going to copy this into a separate column here. Okay, and what I'm going to do here is I'm going to remove those that are actually duplicate. Well, remember, okay, why you have more than one entry for, let's say, GKN1 genes. That is because there's multiple shRNA targeting that genes. But for me to actually consolidate, I just want to know basically when you target that gene, what is the effect. So I'm not going to consolidate all those effects. So I'm not interested in the effect of the individual shRNA, but I'm more interested into the effect of knocking down of the particular genes. So here what I'm going to do is I'm going to remove the duplicate so that you will then get a list of the master list of the genes that is covered in the gene in this library. For example, now after you remove all the duplicate, you left basically about 3,400 genes that is being targeted in this study. Okay. Okay, so the next step, what I'm going to do is basically I'm going to count how many shRNA in this list are actually matched into this master list here. In other words, basically I want to know how many shRNA that come out to give the phenotype that I wanted, okay, within a particular cell line. So to do that, so I'm going to label this header here as all shRNA. And then you will use the command count or the formula count if. So then the range, you can select the range here, okay, the whole range, and then equals to this cell here. So then it will return back, then you will get 3 here. How do you get 3 here? It's because, okay, under this column there is 3 entry with the gene name ALPPL2. So you have 2 here, and there is another one here. All right, so now if you copy this whole string, if I'm just going to uh, log the column, so if I'm going to copy this whole string here, oops, sorry, um, copy this part here and then all the way to the bottom of the list, then you can basically see is that, okay, ATM in the whole library, there are altogether 20 shRNA that target ATM and so forth. Okay, now let's look at how about the cell line. So how many of the shRNA that come out as a hit? So basically you just copy this cell and then you put it across. So then it will actually match. So for example, in this column, how many of how many of the gene in this column have a match with this cell here? And the answer is that is 0. So that means that, well, in BXPC3, none of the shRNA that target the ALPP2 actually give a Z-score that is less than 0.2. You can copy this all the way down as well. So for example, in AMBR1, so then you can see that, okay, there's one instances that occur here. That's why the count is equals to 1 here. So what you can do is that then you can copy this formula so across to the whole array. So then you can, after that, then you can actually get a quick count of, okay, how many shRNA is actually came out as a hit. Okay, sorry, I'm going to where is my list? Okay, so I'm going to put it until here. So then now you can see that, okay, so quite a lot, okay, that's how you can see, okay, how many shRNA that actually uh, give you the z-score of -2 in all the cell lines that you have. Okay, by now you should have this table here that show you how many shRNA that could induce a z-score of less than -2 in each of the cell lines. For example, for SSX1, basically there are 3 out of 33 shRNA that give you a z-score of less than -2 in the BXPC3. So now the next thing what I want to do is basically to identify which shRNA that I want to identify for the hits as a for following study. Now, by convention, basically to make sure that the phenotype that I wanted are actually a real phenotype, by convention, basically you need at least 2 independent shRNA that give rise to the same phenotype to confirm its activity. So in this case here, so those those hit, for example, AMBR1, only have one shRNA that give me the phenotype that I wanted. So they might not be as strong compared to, let's say, in these guys here, which actually have 4 shRNA that give rise to the same to the phenotype that I wanted. So what I'm going to do now is basically to identify the cutoff by using by defining the hits as in the genes that when knocked down by at least 2 independent shRNA that give me the z-score of less than -2. So what I'm going to do here is basically I'm going to count across all the cell lines how many cell lines actually can give me at least 2 shRNA that is considered as hit. So what I'm going to do here is I'm going to use again the formula count if. So, and this will be the whole range from here to here. And the criteria would be more or equals to 2 shRNA. So, and what you can do here, oops, sorry, I forgot to put in this one here. Okay, here. So you can see here is that basically what it means here is that for this ALPPL gene knockdown, basically there is only one cell line, okay, in this case here SNU410, that actually have 2 independent shRNA that have less than the z-score of less than -2. So if you copy this one all the way down, basically, then you can actually give you the list of gene knockdown that will induce the phenotype in the different cell lines. For example, you can see that, well, this one here, BOP1, when you knock down, basically almost all the cells are affected. There are 18 cell lines that is affected, except for SNU 410, basically. So by doing this, basically, then you can identify and prioritize, okay, which genes that you want to look at. For example, altogether here, you have how many cell lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. You have all the 19 cell lines here. So is there, oh, that's quite interesting. So there is actually some of the genes when you knock down, they can actually inhibit the growth of all the cell lines. And I want to know what this gene is. So I'm going to filter it down and see which one is it. So it's a bit slow. So that's a bit slow here. So, but anyway, so I hope that you roughly get the sense of how this analysis might work. So next we will be moved into another method. Oh, here you go. So the result is here. So now these are the list of the genes. So this is quite interesting. This is the one that when you knock down, at least two of the shRNA that target these genes can actually cause the growth arrest or inhibit the cell proliferation in all the pancreatic cancer cells. And this will be something that will be quite interesting, and you can use this as one of the hits as well. So it depends on what is the cutoff that you want to use, and you can filter it accordingly. Okay, the analysis that you saw just now are basically based on the cutoff, meaning that okay, I'm just going to interested to know how many shRNA that give me the C less than -2. Okay, for example. Now there's also another way that you can look at it by calculating the average of the of each individual shRNA that target the particular gene. So, and to do that, okay, you can create another column here if you want to. Okay, you can create two more columns here. All right. So which is fine. I think I can just copy and paste this as number. Now, so what I'm going to do here is basically I'm going to calculate the average. Okay, what is the average C score that is induced by knocking down of ALPPL2, for example. I'm going to use the formula average if, okay, oops, average if. So then, yeah, then you can actually see, okay, the first thing you need to identify the range. So this is the range of the original data set, which is basically looking at the C score here. So, and this will be the so-called the range. The range will be this one here in the column C. Okay, and then your criteria will be to match it to uh, this cell, and then the number that I want to average it are basically located at this column. Okay, so and when you press enter, and they will tell you then okay, uh, for BXPC3 the average C score by knocking down ALPP2 is actually 0.44. Okay, so if you want you can cross-examine it, but basically it should be quite accurate. So now, so I'm going to copy this cell and then to populate it in each of the column. So by basically locking the range of this one, I don't have to lock it, but yeah, I do need to lock this part here. So so now you can see that if I'm going to copy, okay, if this one is here, then I also need to lock this column as well. Yep. So now when you copy it down, so then you will get that if you copy across, you can see that, well, it will automatically match it to the C score, C column. So this is your, this is the column for the gene symbol in the whole data set. And then you also have, and then match it to this column here. Okay, the AS, I have locked it. Okay, and calculating the C score return would be at F column. See, it automatically move across. So now what I can do here is basically I can just copy the whole cell here, and then I can uh, and go all the way down to the list. Okay, and then it will then calculate the average C score for each of the cell lines following the knockdown of the particular gene. So this will be the average of the C score that is from all the shRNA that have been used in the library. Okay, so now you have all the average C score for each particular gene. The next thing will be the easiest. Okay, you can calculate the mean of the C score for all the cell lines. Okay, by calculating the average across, basically. Then go down the table. So then you can calculate this, and again, so if you want to identify what are the hits, so you can also base on the average C-score cutoff. For example, if I want to look at only less than or equals to -2, so what would be the genes that could give me the average C-score across all the cell lines with at least -2 C-score? So you can do this type of analysis. So this is one way to look at the data set and identify the hits using the C-score. So in the next few videos, I'm going to show you how you can also use the other two methods, RSA and also rigor. And how do you decide which hit methods are you going to use? So if you want to have the most stringent analysis, you can always use the tree. And if all the three methods giving you the same list and those genes that are identified by all the three different methods, then you will have a higher confidence that they are actually giving you a significant phenotype that you wanted. But of course, a lot of the papers is up to you. Some only use C-score, some choose to use RSA only. So it really depends. So there's no absolute consensus what you need to do. So, but basically, this is one way. One way that I've shown you here is basically by using the C-score. Okay, so that's all for this video. So I will show you in the next video on the other methods as well. Thank you.